Students, here we are with 2.3. We'll review some of the things you learned in Algebra 2 and Pre-Calc about polynomial and synthetic division. First, to get a good idea about dividing polynomials, we review the joy of longhand division way back from arithmetic, because some of the same terms apply. When you take 543 and divide it by 17, first you see how many 17s you can get into 5. You can't any. 54, you can get 3. 3 times 17 is 51. Subtract 3, bring down the 3, 33. Can't quite get 2, so we're only getting 1 there. 17. It's number 31 and 16/17 as your final answer. Now let's compare with what we do then with division algorithms with polynomials. See, we've got the same type of ideas here, where you have a dividend, a divisor, which is 17, and a quotient. But now, instead of just being numbers, these are all algebraic polynomials. Let's try practicing one of these, using our little algorithm up here. That is, we're going to put x squared minus x minus 3 on the left, and then divide by this. And I'm going to put these in order, with the highest degree term first, x to the 4th plus 5x cubed. I'm going to make room for a 0x squared plus a negative 20x plus negative 16. Negative 16. Okay, so our first thing is to see how do we get x squared and x to the 4th. Well, that's going to take an x squared. So let's do this next step in red here. It's going to take x squared times x squared to get to x to the 4th. So we put an x squared here. Now you got to take that x squared into everything that you had in the divisor. So that's x to the 4th. X squared times negative x is negative x cubed. X squared times minus 3 is minus 3x squared. And then subtract. Now, it's really not written in here. I'm going to do it emphatically. But remember when we were doing the longhand before, we didn't put them in. But I'm just going to emphasize the fact that everything in here gets subtracted. So the x to the 4th cancel out. 5x cubed minus a minus x cubed is actually 6x cubed. 0x squared minus a minus 3x squared is actually plus 3x squared. All right, then we bring this next one down, plus negative 20x. And let's look for our next thing for the match here. Let's try this in black. How do we get x squared into 6x cubed? Well, we need a 6x. Notice how that lines up in this column with the x's. 6x times x squared is 6x cubed. 6x times minus x is minus 6x squared. 6x times minus 3 is minus 18x. And we subtract again. So that makes the 6x cubes cancel. 3x squared minus a minus 6x squared is 9x squared. Minus 20x minus a minus 18 is minus 20x plus 18, so that's plus negative 2x. We're still not done because this has to be smaller than this in terms of degree. So notice how this is a second degree. So we have to think of how does x squared become 9x squared? Well, that's with a 9. So plus 9 will give us 9 times x squared is 9x squared. 9 times minus x is minus 9x. And 9 times minus 3 is minus 18. I notice from before we probably would move this negative 16 down here like that. So now when you subtract, we get 9x squared minus 9x squared. Subtracting this quantity like this. We get 0x squared minus 2x minus minus x is 7x. And then minus 16 minus a minus 18 is minus 16 plus 18 or plus 2. So your total answer then is the quotient up here, x squared plus 6x plus 9, x squared plus 6x plus 9, and don't just say remainder 7x plus 2. Put the 7x plus 2 over your divisor, x squared minus x minus 3. There you go. There's your final answer from longhand division. Kind of a pain. Now remember how you check these too. We can check it by multiplying these two together and then adding on 7x plus 2. Now that's a lot of work. Check this out, flange is fallible. And in my checking of the solution, by multiplying the divisor times the quotient, I came up with this big expression. And then when I added on the remainder, it did not match the beginning. So I did something wrong in the constant term and I found it. It was right here. 9 times negative 3 is not negative 18, but negative 27. So we can fix that now. Over x squared minus x minus 3. Now let's see if that works out when we do that over here. We add on 11, and it makes minus 16, and that matches with the original problem. Okay. There we go. That was our original quotient. Yeah, minus 16. So you can see longhand division is a big pain. And so that's why I came up with synthetic division. Now, synthetic division has to be in the form of x minus k. And so the number you subtract from the x is what you put in the box. It goes right there. So we start by putting 6 in the box. I usually just put the box like that. They make a big thing like that, and they make a long line like this. And then all the coefficients. 3, negative 16, 0, negative 72. Notice they skipped the x here. Then you just bring the 3 down, then multiply by the number in the box. See this, a to ka. Multiply by the number in the box. So that's 18. This is 2. 2 times 6 is 12. Add them up, you get 12. 12 times 6 is 72. Add them up, we get 0. So it turns out that this factored in there nicely. And you get for your answer 3x squared minus 2x plus 12 plus no remainder over x minus 6, or just 3x squared minus 2x plus 12. Now the remainder theorem gets at the fact that we can find remainders quickly. And this comes from the idea that when a polynomial is divided by x minus k, the remainder is fx. Why? Well, here's the proof. If you take a polynomial and divide by x minus k, some p of x, you're going to get some quotient polynomial plus a remainder also divided by x minus k. So let's use an LCD now of x minus k and multiply both sides of the equation by the LCD. You get p of x equals q of x times x minus k plus the remainder. And so that remainder is what you get when you divide p of x or f of x by x minus k. If x equals k, now let's look at what p of k is. P of k is q of k times k minus k plus r. I just put k in wherever it's on x. Well, this is 0, so we just get p of k equals r. So the remainder is equal to the value of the function at that point. So we can come over here now and quickly do these problems with synthetic division. F of 1, we can put 1 in the box and put down just the coefficients 4, negative 16, 7, put a 0 for the x term, 20, zip, bring down the 4, multiply by 1, 4, add negative 12, multiply by 1, negative 12, negative 5, multiply by 1, negative 5, add negative 5, multiply by negative 1, you get negative 5, and add, you get 15. So this means f of 1 equals 15. And that should correspond to the point 1, 15 on the graph. And conveniently, I already did this up on my calculator, and sure enough, 1 is going to 15. You can do this in your calculator too by putting this in, and then using trace, and then just entering 1 in. And hit enter. And it'll take you right to that point. Let's try another one of these. Find f of negative 2. Jot down the coefficients again. 4, negative 16, 7, 0, 20. Zip. Bring down the 4. Multiply by the number in the box and add. Multiply by the number in the box, 48, and add 55. multiply by the number in the box, negative 110, and add negative 110. Multiply by the number in the box, 220, and add 240. So by my calculations, negative 2 goes to 240. That is f of negative 2 equals 240. Let's see if that's what we got in the big picture. Negative 2 went to 240. We can check the others in class. Now, the factor theorem is an extension of the remainder theorem. If your remainder is 0, then it factors in and goes in evenly. We're going to try this on this problem here. We're told that x equals 2 is one of the roots here. First, we can verify it. Put 2 in the box. 1, 0, negative 7, 6. Remember, you have to have 1 for every possible power of x. Bring down the 1, multiply by 2, and add. Multiply by 2, and add. Multiply by 2, and add. And sure enough, that means that x equals 2 is a root. Further, it means that x minus 2 is a factor. And we can continue factoring this by looking at the depressed equation. This is x squared plus 2x minus 3 equals 0, which factors into x plus 3 times x minus 1. So we get x equals negative 3 and x equals 1. And there's two things we get out of this then. We can say that all the roots are the one we're given 2 plus the one we found from the depressed equations. And if we want to factor the whole thing, we know that x minus 2 is a factor. And also we have the factoring here of x plus 3 and x minus 1. Synthetic division is so handy. Now sometimes you're given 2 factors, 2 roots. Let's see how this is going to work out. We take negative 2 as a first root, because if x plus 2 equals 0, if x plus 2 is a factor, that means x plus 2 equals 0, that means x equals negative 2. That's why you have to write it as what is being subtracted from the x. That's what goes in the box. So we try negative 2, 8, negative 14, negative 71, negative 10, and 24. Zip. Bring down the 8, multiply by negative 2, negative 16, we get negative 30. Multiply and we get 60, that makes negative 11. 22 makes 12. Negative 24, 0. There you go, it works. But here's the key thing. Use the depressed equation now, and now we're going to put 4 in the box. Bring down the 8, multiply by 4 is 32, 2, 8, negative 3, negative 12. Bazinga. Look at that. They both work. Now what that means is we've got a depressed equation, a doubly depressed equation. It's kind of like you. If you misbehave, the parents are going to take away your driver's license and ground you. And you become doubly depressed. So stay on the straight and narrow, kids. Doubly depressed, we're down to 8x squared plus 2x minus 3 equals 0. I wonder if that factors. Let's try a few things. How about 2x and 4x, and then put the 3 somewhere? 12, yeah, minus 1. 12x minus 2x is, no, 12x minus 2x is 10x, though. That did not work at all. The other way. 2x plus 1, 4x minus 3, that's 4x minus 3. Oh, we're so close. Make this a plus and make this a minus. Now we got minus 4x plus 6x is plus 2x. There's the minus 3, there's the x. So we can get the other roots then. We've got it fully factored if we want it. And we can get the other roots. So the roots are x equals a half, x equals negative 3/4, and also from before we had x equals negative 2 and x equals 4. Okay? Flange out.